Hey, it's Kavya here. Imagine this. You have thousands of photos in your computer, and suddenly you remember you took a beautiful sunset photo while hiking in the mountain, and you're gonna find out. All you remember is that concept. You don't remember the file name, you don't remember the creation date, you remember the folder. And if you try to show me like that pictures of mountain and computer finds it instantly, how is that possible? The answer lies on something called vector database. Suppose we store a file in a regular database. The database can save the file itself, creation date, or something text like sunset, orange, or warm. But if you ask, show me the images of mountains, the database struggles. Why? Because humans think in meaning, but computers think in keywords. This gap called semantic gap. But if we could teach computers understand the meaning of data, not just labels, not just file names, but the actual concept inside, that's exactly what AI embedding models do. Instead of storing data as a single record, it converts into something called AI embeddings. Think of it as an mathematical fingerprint of name. Every image, every document, every piece of text can be converted into long list of numbers that captures its essence. Once data become numbers, it's easy to find for a computer, and that's the breakthrough. So, what is vector database? A vector database is a specialized database designed to store and search these vector embeddings. Let's go back to our mountain photo. So here we have mountain photo and a beach photo. And these are the values that it stores in vector database. So this one has 91, but this one has 12 because this one has mountain and this one has a flat beach. Because that's why this have higher value and this one is low. But if you look at here, something similar, right? This one has 83 and this one has 89 because these are sunset photos. I mean warm colors. So that's why it has similar values. Instead of searching for exact words, a vector database searches for vectors that are mathematically close together. In other words, similar meaning equals similar vectors. This allows computer to find the content that feel related, even when the keywords are completely different. Traditional databases aren't designed to understand meaning, but vector databases are. They search based on semantic similarity rather than exact matches. Another challenge is scale. Modern AI applications have millions of vectors. Each vector can contain hundreds of even thousands of dimensions. Comparing every vector by vector would be extremely slow. That's why vector database was clever indexing technique as HNSW and IFF. These algorithms quickly locate the nearest location when checking everything. Think of it as using a GPS instead of searching the whole city. So, where is this used right now? You might be surprised. You have already used this system powered by vector search every day. AI chatbots, RAG applications. If you remember only one thing on this video, remember this. Traditional database search for exact matches. Vector database search for meaning. Traditional database answer the question like what matches this keyword. But vector database answer what is more similar to this. By converting data into vector embeddings and searching through mathematical similarity, vector database make AI applications smarter, faster, and more human-like how they retrieve information. So next time you upload a document to ChatGPT, ask question about PDF, search for similar image, or get recommendation from your favorite app. There's a good chance a vector database is working behind the scene. It's one of the most powerful technologies in modern AI applications because in real world, overflowing with information, finding exact matches is no longer enough. What matters is now finding the meaning. And that's exactly what database will